Look at this. 60 million stars in a single frame, the glowing core of our own galaxy, sharper than any visible light photograph ever taken of it. And here is the strange part. The machine that captured it was not built to look at this. It was not built for light at all. The telescope behind this image is called Euclid. Its real mission is to hunt the part of the universe that has no glow, no shine, nothing a camera can point at. The part that is, literally, dark. This is the story of how we try to see the unseeable, and how a dark universe detective turned around and took the brightest portrait in the sky. Start with a number that should bother you more than it does. Everything you have ever seen. Every star, every planet, your own body, this screen, is made of ordinary matter. Ordinary matter is about 5% of the universe. 5. The other 95% is something else. Something that does not shine, does not reflect, and has never appeared in any telescope. Scientists split it into two great unknowns. About 27% is dark matter. About 68% is dark energy. They are not called dark because they are sinister. They are called dark because we are in the dark about them. The words are honest labels for two enormous holes in human knowledge. So the bright universe we grew up believing was everything turns out to be a thin skin on a much larger invisible reality. Which leaves the hardest question in modern science. If you cannot see something, how do you prove it is there? The first clue came not from staring into the dark, but from watching how things move. When astronomers measured how fast galaxies spin, the numbers did not add up. The outer edges of spiral galaxies were whirling far too quickly. Going by visible matter alone, those galaxies should have flung themselves apart long ago. Like a merry-go-round spun too fast, the riders should have gone flying. They do not fly apart. Something is holding them together. Something with mass and gravity that we cannot see. That invisible glue is dark matter. It gives off no light. It blocks no light. It announces itself only through gravity, by pulling on the things we can see. There is a second fingerprint, and it is more beautiful. Gravity bends light. When light from a distant galaxy passes a large clump of mass, that mass warps space and curves the light, like a lens. Astronomers can measure that curve. And when they map all the bending across the sky, they find far more mass doing the bending than the visible stars and gas could ever account for. So dark matter is not a guess plucked from nowhere. It is the name we give to a pull we can measure but cannot photograph. We know its weight. We do not know its nature. If the universe is already feeling stranger than you expected, do like, comment, share and subscribe. It genuinely helps this channel reach more curious people. Dark matter pulls things together. Dark energy does the opposite, and it was found almost by accident. In the late 1990s, astronomers were tracking exploding stars in distant galaxies to measure how fast the universe was expanding. Everyone expected the expansion to be slowing down. Gravity pulls inward, so over billions of years it should be applying the brakes. Instead, they found the expansion is speeding up. The universe is not coasting to a stop. It is flying apart faster and faster. Something is pushing. Some unknown property of empty space itself appears to carry a pressure that drives galaxies away from one another. We call it dark energy. It is the largest ingredient in the cosmos, and the one we understand least. Put the two together and you get the real shape of the universe. A web of invisible dark matter holding galaxies in place, and dark energy woven through everything, slowly tearing that web apart. The stars are only the glitter on top. This is the problem Euclid was built to attack. Euclid is a European Space Agency mission, launched in 2023. It sits about 1.5 million kilometers from Earth, far beyond the Moon, in a stable spot where it can stare into deep space without the Earth and Sun crowding its view. Its job is enormous. Over 6 years it will chart roughly a third of the entire sky, measuring the shapes, distances, and motions of billions of galaxies, some so far away that their light has been traveling toward us for 10 billion years. The European Space Agency describes the goal plainly. Euclid is there to reveal the hidden influence of dark matter and dark energy on the visible universe. But how do you map something invisible? You map its effect. Dark matter bends light. So Euclid measures, with extraordinary precision, the tiny distortions in the shapes of distant galaxies, the faint stretching caused by unseen mass their light passed on the way to us. Collect millions of those distortions and you can draw a map of where the dark matter sits, without ever seeing the dark matter itself. And by measuring how galaxies are spread out at different distances, which means at different moments in cosmic history, Euclid traces how fast the universe has expanded across billions of years. That expansion history is the fingerprint of dark energy. So Euclid does not photograph the dark universe. It photographs the shadow the dark universe casts on the bright one. Detective work, written in starlight. Which brings us back to that opening image, because it is the opposite of Euclid's day job. To study the dark universe, Euclid normally looks away from the Milky Way, out into the quiet, faint, distant cosmos where galaxies sit far apart and the view is clean. The crowded, blazing center of our own galaxy is exactly the kind of place a survey telescope avoids. Too bright. Too packed. So the team did something bold. They turned Euclid toward the brightest, most crowded patch of sky there is, the galactic bulge, the dense bubble of stars at the heart of the Milky Way, and held it there for about 26 hours. The risk was that the telescope would be blinded, the way your eyes are when you walk from a dark room into sunlight. It was not. Euclid's camera was sharp and steady enough to pick apart individual stars inside that glare without washing out. As the mission team put it, they pointed Euclid at the brightest area of the sky, and it performed superbly. The result is the largest, most detailed visible light image ever made of the Milky Way's core. More than 60 million stars, with glowing gas clouds and star clusters, stitched together from 9 separate pointings, each one covering a patch of sky larger than the full moon. To grasp the scale, each Euclid frame captures an area hundreds of times wider than Hubble sees in a single shot. The European Space Agency notes that to match this one mosaic, a ground observatory like Keck would need around 2,000 hours of work. Euclid did it in just over a day. Here is the elegant part. The bright image and the dark mission are not really separate. They are the same skill, pointed 2 different ways. The very quality that lets Euclid map invisible dark matter across billions of faint galaxies, sharp, stable, wide vision, is the quality that let it survive the glare of the galactic center. Proving it can handle the brightest, most crowded sky is proof of how good its eyes are for everything else. And the image is not just a trophy. The dense heart of the galaxy is the best place in the sky to hunt for planets around other stars, using a method called microlensing. The European Space Agency says this single image already contains dozens of known planetary systems, and will act as a reference frame for the telescopes that come after it. So a machine built to weigh the invisible also became a tool to find new worlds. The same eyes, 2 missions. We tend to think seeing is believing. The dark universe asks us to flip that around. 95% of everything cannot be seen, and yet, carefully and patiently, we are proving it is there, by reading its gravity, its lensing, its push and pull on the light that does reach us. That is what makes Euclid quietly remarkable. A telescope built to study what gives off no light took one of the most luminous photographs in the history of astronomy. The brightest image, made by the hunter of the dark. We are learning, at last, how to see the unseeable. If this episode earned it, do like, comment, share and subscribe. That is what keeps Plain Evidence going. This was Plain Evidence. Thank you for watching. See you in the next one.